Hey guys, welcome to Programming Knowledge. In this video, we'll be talking about ASCII or American Standard Code for Information Exchange. So, what is this? This is basically a number which is associated with every character. Let me give you an example. The previous video we wrote a program for adding two numbers, right? So same thing we are going to repeat over here. So let's say enter first number, and I'm going to create a memory location and take an input inside that location. Let's say A, right? So instead of A1, I'm just going to name it A, and same thing is going to happen. Enter second number. Okay, let me give a space over here so that it looks nice. And int B, C and B, and int sum equal to A plus B, and we're going to just say the sum is and the sum, right? We wrote this program in the previous video, right? So you all know what it is going to do. It is just going to ask for two numbers. We are going to input that, and it's going to process those two numbers. It's going to add those two numbers, and then it's going to store the value inside this memory location, that is sum. And then here the memory location is invoked, and the value inside that memory location is going to be displayed onto the screen. Here now, what if I just change this int to some other data type, let's say char, and here also let us say char. Now let us run and check this out. So here it did not show any error and it is working perfectly. So now if I just say 1 over here, enter first number, that is 1, enter second number 2, and now the sum is going to be something different. So you might think it's going to throw an error because we are trying to add two characters, but as I told you, characters are actually a form of integers only. Computer stores character in form of integers. So this addition is completely valid, and the value the sum is going to store is actually the sum of the ASCII values of those characters. So one holds the ASCII value of 49 and 2 holds the ASCII value of 50. So once you press enter, you are going to get the sum as 99. That is 49 plus 50, that is 99, right? That is why I told you that representing data in different forms is very important. So if you write 1 like this, it is going to be, let me write separately somewhere in the bottom. So if I just type 1, this is an integer. And if I put it like this is a character. So that is why I told you the way you represent data is very important. So instead of size, that is 4 bytes and one byte, so that is also there, but here this integer is actually processed as 1 only. So it is processed as 1, and this thing, it is processed as 49. So this is the number it is going to process when you just say a character 1, right? So every character in your keyboard has a hash key value. So to look at that, just go into your favorite browser and check for ASCII over there. And here you might see many links, so just click any of them. So they are going to give you a table of ASCII values. So this is the ASCII value, and this is actually the decimal, and this is the hexadecimal representation. You don't need to bother about the hexadecimal representation. What is important is this decimal representation and the symbol associated with it. So you can see the null is associated with the ASCII value 0, and there are many other characters. So 13 is actually the carriage return, that is the enter key, and 27 is the escape key. So here you can see 27 is the escape key. So what is important is our numbers and characters. So those ASCII ranges are only very important to us. We'll be using them interchangeably while dealing with data, right? So mostly data consists of only numbers and characters. That is why we need to remember the range of numbers and characters ASCII values. So here number starts from 48. So here you can see 48 is 0. So it starts from 0 and goes up to 57, that is 9. So this is the range of ASCII values. So 48 to 57, that is the range of numbers. And capital A starts from 65 and goes up to 90. 90 is capital Z. Likewise, small a starts at 97 and then it goes up to 122. So 122 is small z. So these are the ranges. So let me write that down here. So let me put a comment. So this is a multi-line comment. So 0 starts at 48 and 1 is 49 and likewise, right? Okay, I put an underscore here. Same way, capital A is 65, capital B is 66, likewise, and small a is 97, small b is 98, and it goes on. So these are some of the important ASCII ranges. We will be dealing with this while we are working with the conditions and all those things. We will be looking at that in a later video. But these are some of the ASCII values which we will be using very frequently. So it is better that you remember the starting value, because the other values you can directly derive from the first value. So 0 is 48, capital A is 65, and small a is 97. So these are some of the values that would be very helpful if you remember these things. So now you know how to predict the output, right? So let us try with some other characters also. Let's just put this as a character only. So instead of int, I'm just putting it as char. Now if I try to build and run this, so here it is asking for the first number. Let's say some random character. I'm just putting this question mark and this apostrophe. So let us look at the table. So question mark is 39 is the apostrophe and 63 is question mark. So 63 plus 39. So now if I just put it, the sum is f, that is over here 102, right? So that is how ASCII ranges work. So they work just like numbers, just that the character is associated with a special number and you need to know the number to actually correctly predict the output. So sometimes you may miss it out, right? So sometimes you may put a character and try to add two characters and see absurd answers. Those are not absurd, just that your logic is wrong. So here, if I just put an int and character, sometimes this happens. So if I just put an int over here and char over here and then try to build and run this. So first I will put 1 and then put an A. So now the output is going to be B, because 65 plus 1, that is 66, and the character value of 66 is B. So you can check that from this table. So here you can see capital B is 66, right? So ASCII values are just like numbers. So you're just going to operate them as you're going to operate on numbers. So you can put, you can add one or you can multiply it so into two. That is also possible. So it is only character. So let's just make character. And then once I try to run this, here it is 1 and 2. So here the sum is B, because 48 into 2, that is sorry, 49 into 2, that is small b, right? That is 98. So here you can check that out. So 49 into 2, that is 98. So 98 is b. So you can do that. You can divide those things. So that's all for this video. I hope you enjoyed, and in the next video we'll be talking about conditional statements in C++. Till then, happy coding.